Hi. Okay, so I'm going to be talking about truth tables, and I might be preaching to the converted here, but it's what happens when you get asked lastminute.com to do something. And I thought, all right, why am I talking about this? Well, the reason this topic for me came up was because very recently, by the way, I'm going to be showing some code, but I don't know if you guys are going to be able to see it, so bear with me if you can't. But we were looking for a new developer, hence this is where Yoke came in. And I gave every single one of them the same test during the interview, which was to write a method to return the number of days in any given month. So it would accept a month argument and return the number of days. Something fairly straightforward and fairly simple, or so I thought. Unfortunately, as it turned out, there were a huge, wide variety of responses that I actually got back from every single candidate. So I've listed them here kind of in almost in order of what we received, but I'm consolidating everyone's experiences into some kind of a progressive order. So we have here obviously one loop that started off from I equals 0 to I is less than 32. Why? I think the guy was just trying to work out, going through every single one and working out, right, does January have 0 days? Well, yes. Does it have 1? Yes. And I have no idea where he was going with that, but eventually, to suffice to say, he got stuck, he didn't get the job. Next person then decided, okay, fine, arrays are the way to go. So they actually constructed two completely separate arrays, one for the month, one for the days in each month, and then somehow got stuck on how to combine the two together. Again, unfortunately not a very good start. Then eventually, after a little bit of prompting, then they worked out, okay, associative arrays are the way to go, which, okay, fine, that's kind of the way to go, you're going to get the correct answer there, except now you've got a major problem. In that February doesn't always have 28 days. And that was part of the thing that I was going to check was, are they aware of the edge conditions and how to write code to get around that? And unfortunately, they got stuck because when they first started to write something, by the way, I don't know if many people are aware, a year is a leap year, not only when it's divisible by 4, but it also cannot be divisible by 100 unless it's also divisible by 400. So for example, the year 2000 is a leap year, but 1900 isn't, 1800 isn't, even though they're divisible by 4, but it's because they're also divisible by 100. So centuries are not leap years unless they're divisible by 400 as well. So that presents a nice little simple logic test again. Also I thought. So we had attempt number 4 here, where unfortunately the next candidate got stuck, but you can see kind of where they were trying to go to, which was to write something like this. Now I'm not sure if you guys can see that clearly, but you've got 3 nested ifs here, returning true, false, or true, depending on which condition it hits. In reality, I'm sure probably the more experienced developers will say this is a really, really ugly bit of code because it's just too verbose, very, very verbose for what it needs to do. And the one thing that really surprised me was that none of them were aware of this simple concept of truth tables, which is literally you make a table of all of your parameters. So you've got here, as I mentioned, in determining whether a year is a leap year, you need at least 3 parameters. You need at least 3 checks. Is it divisible by 4? Is it divisible by 100? And is it divisible by 400? So you begin by creating a row of the most obvious condition, or the first condition that you need to check. Is it divisible by 4? If the answer is no, you don't need to check anything else. The answer is going to be no. You can see here in the second row, is it divisible by 4? Yes. Then the next condition, again, you're just making up these conditions, putting out all of the permutations, rather all of the valid permutations. So is it divisible by 100? No. Okay, that's fine. Automatically it's a leap year. If it's divisible by 4 and divisible by 100, but not by 400, it's not. And in the last one, divisible by 4, divisible by 100, and divisible by 400, yes, it's a leap year. So you can see that there are here 2 critical rows. There are 2 specific rows here where your condition should return true. And the way a truth table works is for you to be able to visualize this and work out what are the common features between the rows that all return true. So obviously the common feature here is divisible by 4. And then it has to either be not divisible by 100, because you've got that X there. Actually, a pointer would have been good. Have we got a pointer? No, we haven't. Okay. Or is divisible by 400. So hopefully, by drawing it out in a table, and normally if I'm writing something complex, I'll just draw it on a scrap piece of paper. But putting things down like that really, really helped to simplify what your logic should look like, and also help you write the code. So again, literally just writing that out in code, you've got, if the year is divisible by 4 evenly, and either it's not divisible by 100 or divisible by 400, that's a leap year. And that's literally about as concise and neat as you can make it. I'm sure you guys will probably agree that that is a much, much better example. Again, purely driven by truth tables. But that's not it. I mean, you can, depending on how creative you want to be, you can go another step further. For example, back to the main function now, returning the number of days in a month. Again, let's make another table now. We've got all of the months across the top, and you've only got 3 possible return values, 28 or 29, depending on the leap year, 30 or 31. So again, we can see here, 28 or 29 is the exceptional case only for February. Otherwise, you've got 4 months that return 30. 30 days have September, April, June, and November, and everything else is 31. So again, using the truth table as a template, you can just write the code following that. If the month is February, then whether it's a leap year or not, return 29 or 28. Otherwise, if it's one of the other exceptions, September, April, June, or November, return 30. Otherwise, return 31. It's literally, it makes the code that much easier to read and to follow. And again, I'm sure this can be simplified even more. You can use the ternary condition there, or go one further, as I would prefer to do, and just make the year optional because you don't always need it. But essentially, just by having or being aware of this concept of truth tables, I'm hoping that maybe someone here wasn't aware and this might help them. By the way, the position's been filled now, so if anyone's trying to use this now for the next interview, we fill the position now. But yeah, that was basically it. So I just wanted to highlight that and just show how correct use of truth tables can basically make writing complex Boolean logic, not that that was complicated, but obviously extrapolate it to your own situations, that much easier. I think I'm within my time. That was it. Yeah, great. Thank you very much.